Hi Riley, you should be able to hear me better today. I'm not at the tournament. Alright, so we're starting on the combinations assignment, and you asked for question 5 and question 7 on that one. We've got 13 forwards, and he needs to make 4 lines consisting of 3 forwards. So he thinks he'll be able to try every possible combination of forwards, find the number of combinations of forwards the coach can make, and determine if this is feasible in a 62 game season. Okay. So there is a detailed answer for this. I posted the answers along with the assignment on the calendar entry for that day. So if you have a look at that, I'm not sure how much more I can explain of that. Maybe if we just start with 5A, and I'll kind of try to explain that to you in detail, and if it's just one of the parts of that question that's giving you trouble, maybe you can email me back and let me know that, and I can go into more detail for you on that. If we're looking just at 5A, and he asks how many combinations he can make and if it's feasible in a 62 game season. And so when you think about the fact that you've got 13 forwards, when you're choosing the first line, you need to choose 3 forwards. So that's 13, choose 3. And that's the same thing as writing it this way. I kind of prefer writing it with the C, but it's up to you. So that's the combination that he can use to choose the first line. And then what we do is we multiply it down the road, because whatever combination he chooses there, each one of those combinations can then be paired up with all of the other combinations for the other 3 lines. So it's a multiplication or a product kind of effect that just keeps giving you more and more possibilities. So now that we've used 3 of the forwards, they're no longer available for the second line. So now we're starting on the second line with only 10 forwards left. Again, we're going to choose 3 from them. And so the same idea, for the third line we have 7 forwards to choose from. We're going to choose our line of 3. And in the last case, there's only 4 left, and we can still choose 3 from them. Okay? So if you multiply all of these choose statements down the line, you're going to get the answer that they give you in the answer sheet, and there's over 4 million possibilities for this. Okay, so in a 62 game season, could we use them all? And obviously no, we couldn't possibly use all of those combinations. We need a lot more games, because there's over 4 million combinations that we can create there. Okay, so like I said, I don't know, like there's 5 parts to this question. I'm not really sure if it's just one part or if it's the whole question, but it's going to make for an awfully long video if I go through all 5 of them. So if I leave it at that, now that I've explained that, and if you can look at the answer sheet that was provided and see if that helps make any sense of the other answers, then please don't hesitate to email me back and let me know if there's one in particular or 2 or whatever that you want some more explanation on. I just don't want to waste your time going through like a 15-minute video if you don't need help on all of these, okay? I'm going to make you a separate video for number 7 also, just to keep this short.